playing GTA races. Hey now. Alright, here we go. Got. Hey, Katie, how's it going? Ground kicker. Jay's a scat. Whoa, Jays! What did I do? I just showed my face on stream, man. Whoa! wait, I gotta turn on the other light. Hang on. Hey-ya. Come here. There we go. Alright. Turn on the other light there. What? Into the death, just lucky. There you go. Hey, how you doing? How you doing? Into the death. I hope you're doing well. Goldfishy, yo. I didn't expect you to speak. Sorry. Gemma, how's it going? How's everybody doing? Wow, it's the late Noti gang. Doing your maths, excellent, my man. If you have questions, I'll be happy to take it off your hands. You know, if I can help out in any which way possible, Goldfish, I'll be happy to help. Okay. We are a maths channel first and foremost. I've got many. Okay, that's perfectly fine. Firsty, good to see ya. How was the games with James? Yeah, we did pretty good. I mean, we came in like I think one game we did pretty rough because we got killed off early. But yeah, we played a couple of decent games. Got in like 5th place, 3rd place. Well, it wasn't bad. What am I teaching today? Well, currently it's statistics, but that will change. Every semester will change. So essentially, the spring semester will be over on Wednesday, and then when I come back in the summer, which will be like early June till the end of July, I'll be teaching 2 new classes. So, well, not new for me, but again, new classes for those of you who don't know my content. So that'll be I'll be teaching college algebra and some business math, and then in the fall I'll be doing probably stats again. But yeah. So yeah, it just depends on semester to semester. My classes always change, so I just go with what I'm assigned, and then I just kind of run with it. Or technically, yes, it's about midnight over in the UK. It's about 6 o'clock here, 6 p.m. here in the United States, in the Chicago area anyway. That's the Central Time Zone, not the Eastern Bloc. Eastern Time Zone, that is. So, got like 4 time zones here, so, you know, kind of depends where you're at. Well, okay. All right, Gemma. Well, I'll be streaming off and on here for that little period of time. So kind of like when I'm not busy, then I can stream a little bit. So I don't have a problem with that. You know, if you ask me to, I can certainly do that there. Of course, between times, I'm not working, but I will be preparing for classes for the summer because I still have a lot of back end work to do. So, gotta get those handouts and everything ready. All right, 2a squared plus 5b squared when a is -6 and b is 2. Okay. Just here to pop in and see what you do. All right, you're going to school tomorrow. Very good. All right, Firsty, you have yourself a great night. All right, Goldfish, let's help you out with your stuff. All right, I'm gonna get out the paint tool here. All right, now I like this question, Goldfish, because there's a specific reason why I like this question. Okay, this will prove to be very valuable, actually. Let me be honest with you. All right. Okay, so I'm gonna switch to the main screen here, and I'll show you. You're heading off at dead midnight. Okay, totally understand that. I'm gonna go to the main screen here. Make that 5 now. All right. Now, let me go ahead and write in the problem here that you gave me, Goldfish. And that's plus, okay. Given 2 values. -6. There we go. Okay, so Goldfish. One of the things I do want to make point of here, specifically for algebra, and anything you do in math actually when it comes to problems like these, something that you can take away from this problem. This problem is not hard, but the way you should approach it is the way you should approach a lot of different problems that basically talk about substitution, right? Because at the end of the day, you're talking about, okay, I'm going to put in -6 in for A, and I'm going to put in 2 in for B, okay, Goldfish? So, one thing I do want you to keep note of, and you should always put this in your mind here, okay? So, I do take this part here specifically for you is very, very serious to make things less confusing, okay? Hey, James. So one of the things I want you to do is anytime you substitute, it doesn't matter, okay? Anytime you substitute, always put parentheses around what you put in, okay? This is very important, Goldfish, okay? Always put parentheses around whatever you substitute. You're always going to put parentheses around that, all right? So what do I mean by that here? You gave me two values here, Goldfish. You said A is -6 and B is 2. So if I do that here, I'm going to have 2, and in parentheses, I'm going to put -6 quantity squared, and then plus 5 times B, which is 2 squared. You always, always, always want to do this, okay? Hey, James, we're doing a little bit of algebra here, some substitution. All right? Now, I want to be very specific about this for you. Let me turn down the volume here. I want to be a little bit specific about this to you, Goldfish. The reason is because signs can easily change in any given algebra problem, okay? So, because signs can easily change in any given algebra problem, it's very important you recognize where those changes can happen, and parentheses are going to be the way to go. This is a really good problem to actually showcase that. Now, I'm going to ask you, Goldfish, here, really quick. Let's take a look at what we have here. We have 2 times -6 squared. Now, can you tell me here, Goldfish, what is -6 quantity squared? What's -6 to the second power here? So, this one's just to you, Goldfish. Okay. Now, I'm glad you answered that here, okay? All right, good. Good. You got -72, and that's where the issue lies here. All right, Goldfish? This is the first part of kind of making algebra a bit easier. When you put -6 in parentheses, remember that the way it works, this is how it works for -6. If you put -6 squared without parentheses in a calculator, you'll get -36. However, if you put -6 with parentheses in a calculator squared, you get +36. Because we have to put parentheses around anything we substitute, we actually are going to get +36 here. So we actually get +72 as a result. That is why this note here, Goldfish, is so important, because this makes algebra 10 times easier when you know every single time you have to substitute, you put in parentheses around that. This reduces the amount of sign confusion that you have in a lot of the problems that you may have encountered in the past. All right? I want you to make it a good habit that you do this in the future, because you're going to see and do this over and over and over again in a lot of different types of maths that you'll see that you have there. That's correct, Goldfish. So it'll be 72. Even I can show you here on a calculator. Now, let me show this off here really quick. Well, I'm fine with you guys talking, Katie and Gemma. You guys are fine. That's not a problem. So let me show you this really quick on the calculator here before we move forward. So, all right, we need to clear this whole thing out. Let's clear this. All right. So look, if I do -6 squared, notice it says -36. With parentheses, notice it says +36. That -6 makes a significant difference there, Goldfish. That's correct. Negative times a negative is a positive. Yes, indeed, Connor. So we get 72 for that part there. Now in this part here, we get 5, and 2 squared is going to be 4. So we get 5 times 4, which is 20. Then we just add 72 and 20, and then we get 92 as our result here. All right, and there you go. That'll be the answer to your problem there, Goldfish, for that. Again, it's not a hard problem per se, but the issue really comes down to the fundamentals, okay? That's the one thing I want you to focus on here. I love these kind of problems because if you want to improve in a subject that's already tough enough like maths, it's just getting those fundamentals down that is going to be the most important thing for you, Goldfish, okay? So having these little key tidbits and tricks that you should do consistently in a lot of different types of problems that you'll see later on is going to make things 10 times easier on you in the future. All right? It worked for me as well because I had a tough time with these type of things. So, I want to be sure that you get these fundamentals down as well when you go through these similar type of problems, so you know just to keep applying the same thing over and over again when you do this substitution. Boom, boom, boom. Doesn't matter if it's positive or negative. You're just going to put parentheses around each one of those things. Anything you substitute, there you go. You got it. All right. This goes even in further advanced things such as talking about functions. It works the same exact way that you've done this type of problem here. No difference. Like these are type of problems I definitely pride myself on because they are so like they're like the big key swing things. Yeah, these are the key like Goldfish. These are the key swing things to make maths a lot easier. Like I'm not even gonna joke about that because it's so frustrating when you do a problem and you're just like, how do I know what sign is which? You know, how do I know what goes where? And what do you have to do in this next process? When you're really thinking about it, if you just do these same consistent things that, you know, on the fundamental side, and you think about that word balance, and you kind of put those pieces together, it certainly makes a significant difference on how you approach maths. Absolutely. I understand after the question. I mean, look, you already know, but one of the things is that even the most simplest thing in math, one of the things that you have to understand, Connor, is even the most simplest thing in math, it makes a significant difference on doing something more advanced, right? So one of the things in math is that if you can't do something on the fundamental level, good luck getting something on the more advanced level. That's what I kind of be like, hey, want to be sure that that's taken care of there. For those of you in my 120 class, by the way, remember that I'll get to your next question here in just a second. Goldfish. Remember that the third test is over, and the next part here should be the final and the homework, which is due on May 19th, okay, at 11:59 p.m. All right. I will be posting grades in regards to the test here after this class here today. Was going to do my 102s, but I kind of forgot because I was playing with James. I ain't gonna lie. Yeah, we're going to be going ahead and I'll be going ahead and posting grades for the third test there on your D2L gradebook after this class. So, of course, we'll be taking questions and answers here, doing Q&A here for the final exam if you have any. Go ahead and ask questions here. First and foremost, though, Goldfish has the floor. Go ahead and ask the next question, Goldfish. Go right ahead. I'll be more than happy to help you out. What do we do today? Logs? All right. Logs aren't too bad. You just have to know those properties of logs. They can be a little pesky. But once you know the property of logs to convert it to exponential form and the other algebraic properties revolving around logs, such as multiplication, division, and all that kind of stuff, then and converting them to like plus, minus, and that stuff, then change base. That isn't too bad. So I'll wait for Goldfish. Go ahead. You have the math placement test in order to take my algebra class. Oh, really? Really? You have to take a placement test for that? I thought if you pass my Athena, I thought if you pass stats, you should be able to take my algebra. You have to take a placement test? I'm surprised. I was thinking that I'd taken 102. Yeah, that's kind of dumb. I was like, you just took 102. So why do you have to take a placement test to get into 112? That's kind of weird. Yes, you can multiply a negative number. Absolutely, boss. So, hey, Chips. Thanks, boss. You can multiply a negative number by anything you want. Again, just following the rules of negative, positive, of course. Negative, negative is positive. Positive, negative is negative. So, got the whole gang here. There you go. I'm just waiting for Hey, Natty, how's it going? How was your weekend there? Ground kicker said I want to hydrate. Okay. Nice milk tea there. Sounds weird. Okay. The struggle on one stage was out. Okay. You know the change of positive to negative when moving to the other side of an equal sign, right? Never knew if there's a bracket stays the same. All right. So 2 plus that equals. Okay. All right. You Gucci? Excellent. Yeah, my weekend was pretty Gucci. All right. I was negative 6 squared. But negative because the negative here without the parentheses, boss, the negative is separate than that of the 6. So because technically this is what you're doing. Without the parentheses, you're taking the negative on the outside and you're technically doing 6 times 6 first here. So that's why you get negative 36. Whereas in this case, with the parentheses, you're actually doing negative 6 times negative 6 directly. Negative times a negative is a positive, hence why you get positive 36. Big difference between those two. 8-1, question 5, part F. Okay, I'll take yours next year, Heidi. All right, let me get while waiting for Goldfish's question, if he wants to ask. Oh, he's got a question. All right. The formula for a car: 12 times the monthly payment plus the deposit. B, the cost of the car is £8,000. Find the monthly payment when the deposit is $2,600. Okay, let's do it. And I'll answer Connor's question. Then I'll answer your question, Heidi. Lots of questions. I like this. Okay. So let's go with this premise here. Okay. We have 12 monthly payments plus a deposit of a car is $8,000. Okay. Now let's break this down here really quick, Goldfish, okay? I'm going to type in something here. I'll type in part of the problem here. So we have 12 times the monthly payment. All right. Let's go. I'll put that. 12 times the monthly payment plus the deposit is the cost of the car. Now, one of the things that's important here is to interpret some words here in algebra, Goldfish. So one of the things that I'm going to put out here is just taking a look at some operators. First of all, we have plus and is. Those are going to be our first two guys here. Why are these important? Well, plus is pretty straightforward. It's exactly what it sounds like. You're adding two things together. What are you adding? 12 times the monthly payment. Now we're going to call that 12x here. Okay? Because I don't know what the monthly payment for this car is, but what I do know is that 12 times some monthly payment is going to be some amount of money. We also have the deposit here. The deposit here for the car, according to the problem that you put in, is £2,600. So we're going to put 2,600 right here because we're just 12x plus the deposit. Now here's the most important part here, Goldfish. If in order to interpret the word problem here correctly, the word is a good, clear indicator about where to separate the two things. Why? because is here means equals. Is will always mean equals, okay? If you see the word is in a word problem, that's a clear-cut sign that that's going to be equals whatever that's going to be at the end of the day. In this case, the total cost of the car, which is 8,000 pounds. Okay, so this is 8,000 pounds. Okay. Now, to kind of reflect, actually, this might answer your question here as well, Connor. All right, so now we want to solve for x. And as I put here, the big key to algebra, regardless of anything you talk about here in algebra, the big key to algebra always comes down into the word balance. This is one of the key problems here that helps you understand how balance works. I want to solve for x. I want to understand balance. That's how it's going to roll when it comes to most algebra problems that look like this or any other similar algebra problems. Why? Well, let's think about our goal here. Our goal here is to get x by itself, okay? That's all we want. I want, at the end of the day, all I care about is that x is equal to some random number. I don't care what the number is, because that's my answer technically. But it's like x is equal to blah 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 number. Great, no problem. Alright? So how would I approach that here? Well, I have some roadblocks in my way that are preventing me from getting x by itself. Alright? And this is where balance has to come in. Now notice the first roadblock in my way is this plus 2600. This looks really awkward. Okay? I want to get rid of that 2600, and I want to be sure that it's not on that side with that x. Well, how do I get rid of that plus 2600? Well, won't I do the opposite of plus 2600? Well, what's the opposite of plus 2600, Goldfish? Can you tell me? What's the opposite of plus 2600, my dude? Okay. All right, very good. We're going to subtract by 2600. All right. All right. So again, the key for balance here is basically subtracting by 2600 on both sides, right? If I subtract by 2600 on one side, I got to subtract by 2600 on the other side. So you're correct here in saying, okay, now we have, let's put that down here. Here we have 12x is equal to 8,000 minus 2,600, which is going to be 5,400. That's correct. And then we have, as you stated here, we have 12 times x equals 5,400. How do you get rid of multiplication? Well, you divide. But of course, because of balance, you divide on both sides. So x here is equal to, 450 is correct. So 450 pounds a month is what you get here for the payment of the car. That's correct. So once you set it up, you always do two parts here in any word problem. Number one, interpretation, just like we talked about here in the wording of the problem. And then number two, the calculation. All right. So that's just how it's going to be here. If the car is on monthly payments, there will be an interest on top. Yes. So it actually, in that case, we actually use a separate formula for that entirely, if you were to actually do that out. There is a separate formula for doing monthly payments with interest. So this is assuming no interest, of course, just like a private sale, if you want to kind of call it that. But yeah, there is a separate formula for that you can use. That's a little bit more complex, but since, keeping it simple for now. Oh, no, that's all good, boss. I know you're like, where's my 1 minus r over n to the nt power divided by r over n, man? What's that stuff? I want it. Give me it to the negative nt power. Let's go. Let's go. All right. So that should hopefully answer Connor's question as well, because this is how I basically do balance. Is like even in problems like these, I just go one step at a time. Try not to do 20 things at once, okay? Notice what I did here, Goldfish and Connor. I try not to do 2 things at once. I try to do it one step at a time, just plodding along. One of the things that I highly suggest if you want to get better at maths is just to go slower. Just take it slow. Try not to go from point A to point Z right away. Take it slow if you're having a tough time, and just kind of move at a pace that's comfortable. Gemma, you're out. Your drawing will be just fine. Have you ever seen me draw a horse, Gemma? It's pretty bad. My drawing is abysmal. You're gonna have a lot better time at drawing than I will. All right. Hyde asked 8-1, question 5, part F. Okay. I'll go to that question there. All right, so let's go to this here. All right, let's go there. Let's go to the homework here. Oh my god! Yes, if you space it out, that's right. Yeah, you don't understand how bad it is for me, Gemma, when it comes to drawing. It's the famous horse drawing for a reason. It's the famous. It's bad. It's really bad. my art. I mean, I was kicked out of art class in 6th grade because I was that bad. Let's see, 5 and F. Okay. Go here. All right. I'm gonna get to that part where you mentioned their high day. All right. So what do we have here? What is the probability of random sample of 26 results from the mean reading rate? Okay. So I'm gonna need a calculator for that, because we have mean of 89 and we have a sample. Okay, that's fine. Let's see, where are you? Here you are. Okay. I'm sure it's gonna look 50,000 times better than whatever the hell I put out, Gemma. I think you should be proud of what you tried. All right, so high day for this, we used normal CDF, so we had second in vars. Go to normal CDF. Lower here, what do we have? Mean reading rate of more than 93 words per minute. Okay, so 93. We're gonna put 1 second in comma here for the little e. 99. Our mean here is 89. And we have a sample size of 26, so our standard deviation is 10 divided by the square root of 26. And so that's the adjustment that we have to make there, high day. Paste that in. All right, so the probability here will be 0.0207. Okay. All right, so I'm still in part C here, so the samples of the shows them you expect. Okay. Okay, if you have questions, Athena, please ask. Okay. All right, I'll take a look at that in just a second there, Goldfish. Of the 100 independent samples chosen, we would expect blank to have the sample mean. No, we want obviously A because it's more than. So we want 2. Okay. D. What effect was in increasing the sample size? What does happen in that case? Let's go find out. Let's increase it to 99. Yeah, then it just lowers the probability. Okay. Increases the sample, decreases the probability as n increases. Oh no, wait. Increases the sample size because that decreases as n increases. That's right. All right, so letter E, teacher instituted a new reading program. After 10 weeks of the program, is found that the mean reading result of the speed says 18 grade is 91.9. Okay, good. How much you conclude? Let's see here. A mean reading rate of 91.9 is not unusual. Okay, so you basically have to do it again. All right, let's do it. So let's do this way. What's our new mean here? 91.9. Okay. Oh, we still have the same rate. Okay. This is not. It is unusual. Yes, because it's below 5%. All right, so mean reading rate is unusual since the probability is more than how many decimal places? 4. Okay. 448. Okay. That means we would expect a mean reading rate of 91.9 or higher. Oh, what did I put? Oh, okay. Oops, I put the wrong one. All right, let's try that again. 1.9. Okay, try that. Oh, that's not unusual then, based on that. 0.1093. That should be, what, about 11? Check that. All right, good. All right, let's go to 5. Let's go to F here, okay? All right, so finally got to F here. It says there's a 5% chance that the mean reading speed of a random sample of 24 second grade students will exceed what value? All right, so there's a 5% chance that it'll exceed what value? Basically, what they want you to do here specifically, Haide, is that essentially they want you to find the 95th percentile, okay? They want to find the 95th percentile. Why do I know it's the 95th percentile? Because it says the 5% chance that the mean reading speed of the sample will exceed what value. So essentially in this case, we want to go to second in vars, and we're going to go to inverse norm here in this instance, okay? All right, and we want to find the 95th percentile here. Oops. So our area here needs to be 0.95. Our mean here will be 89. And now we're going to go with 10 divided by the square root of 24. So we have a sample size of 24 here. And we'll default here to left to reflect the 95th percentile here. And we get 92.36 is what we get here for this. And that is how we can get our answer to that question for part F, Haide. Okay? Okay, yeah, so that was the kind of thing where we use inverse norm there, because it doesn't say 95th percentile, but that's what it reflects is the 5% chance is like it'll exceed that value. So it's anything 95% or above, so 95% to 100%. That's why we go ahead and do that. All right, so hopefully that helps there. Okay, yeah, it is a bit confusing on the wording, to be fair there, Haide. But yeah, once you understand that that's what they're talking about, it's really not too bad once you implement it. So, but yeah, it's a fair question, of course. All right, let me get to Goldfish's question here. Because he asked, so let me write it down. We have S is equal to U A. Okay. UT plus a half AT plus a half AT squared. Okay, half AT squared. We're given U, A, and T here. U, 10. A, minus 2. T is equal to a half. Okay, there we go. All right. Okay, so all we're going to do here, Goldfish, is we're just going to, again, we're going to plug in these numbers here respectively. I want you to put parentheses around everything we substitute, okay? So we're now going to implement that strategy that I talked about earlier, okay? All right, so all we're going to do here, in parentheses, put each number in parentheses. Doesn't matter if they're positive or negative. We'll deal with that after the fact. But we have U, which is 10, in parentheses. T, which is 1/2, in parentheses, plus 1/2, A, in parentheses, minus 2, and T squared, which is 1/2, quantity squared. Okay? So, first and foremost, Goldfish, this is exactly what I would like you to do for future problems that ask you to do this, okay? This will make it a lot easier on you at the end of the day, all right? Okay. So, now I'm going to ask you, Goldfish, let's go through each part here. So we have 10 times 1/2. What's that going to be, Goldfish? 10 times a half. Not 50. Think about half of 10. What's half of 10 there? Hey, Rob, how's it going? What's half of 10, Goldfish? That would be 5 times 10 would be 50. That would be, that's, you're thinking 5 times 10. Yeah, 5. There you go, my friend. Very nice. Okay. Now let's look at the right side here. So, I want to ask you really quick here, Goldfish, a quick question. And that is, what calculation should you do first on this right side here? What calculation should you do first based off of order operations? No problem, Heidi. Okay, so we're doing 1/2 squared. Okay, that's going to be the exponents there. Okay. So if you're doing BIDMAS, right? We do the brackets, right? That's fine. But remember that we have an exponent here. You can't do much with the -2, to be fair. But this exponent here is what we have to work on next. So can you tell me what's 1/2 quantity squared? What's that going to be? What's 1/2 squared? What's that going to equal? You tell me what's that going to equal there, Goldfish? I know this may be a little tough, and that's fine. 0.25, okay? Did you find that on the calculator? I have to ask. Alright. Let me point something out here, Goldfish. Alright? So the way you kind of can easily figure this out is if you have 1/2 squared. So 1/2 squared is the same as 1/2 times 1/2, right? I agree it's 0.25, but here's what you can also turn it into. You remember with multiplication of fractions, you multiply straight across. So you got 1 times 1 over 2 over 2. So in fact, you have 1/4, which is the same as your 0.25. Now I'm going to tell you why this is actually important in this problem. There is actually an importance to this problem. Because you have 1/2 here. As in 1/4, which one is... I'm confused why you have 1 is equal to 0.25 there, Goldfish. Little confused. It says 1/4, right? So just 1/4. So 1 divided, it'd be 1 divided by 4, right? So it'd be 1 divided by 4. Right? If you were to do it out, and if that actually equals the 0.25, right? So that's what 1/4 will represent. So if you physically do 1 divided by 4 on a calculator, you'll get the same 0.25. Right, okay. We want to be sure that that's cool. All right. So this is what we have here on the right side so far. So all I'm going to do here, in this case, goldfish, is go in order. I have 1/2 times -2. All right, so what's 1/2 times -2? I'm just going to look at this guy here. All right. What's 1/2 times -2? Perfect. So now I'm just going in order. All right. Okay. And now we have let's do this last part here. We have -1 times 1/4. What's that? What's -1 times 1/4? -1 times 1/4. Okay. Again, I know you're using the calculator for that, but again, depends what your teacher wants. If your teacher accepts decimals, then that's fine. But if your teacher only accepts fractions, then you're going to run into a bit of trouble. All right? So there's a distinct difference here in this case. All right? Oh, you wasn't this time. Okay. Well, in this case, though, you have a negative times a positive. So that's going to be negative. That's just going to be -1/4. That's it. Okay? Now, what it depends upon is what your teacher wants, right? If your teacher's okay with decimals, really, you don't have to do a whole lot here. Oh, you put -1.25. Uh-oh. Well, that's not good. You actually want just -1/4 here. So actually, your answer here would be -0.25 here as a result. So it's not -1. It's not -1 minus 1/4. That would be -1.25. But you'll actually have a -0.25 is what you'll get here in this case. So be careful about that. You have a negative times a positive, and then you multiply the 1 times 1/4, which is just still 1/4. Okay? So be a little bit careful about that, all right? You're trying to add two things together when you're trying to multiply. So that's the one thing you have to be careful about. Now, in this instance here, here we have 5 plus -1/4, or 5 minus 1/4. Okay. Any questions so far, by the way? Let me ask you that. Okay. So next we're going to do 5 minus 1/4 here. And if you're good with fractions here, or common denominators, our common denominator here is 4. So we're going to multiply by 4/4. Remember, 5 can be converted into 5/1 if you want to. So what we're going to get here is we're going to get 20/4 minus 1/4. Subtract the tops and keep the bottom the same. You get 19/4. And then if you need to, I don't know how the teacher wants it to be answered, because you can convert this into a mixed number. And as a mixed number, 19/4 can convert to 4 3/4. This can convert to 4 3/4 if you convert it to a mixed number. But I don't know, it varies from teacher to teacher what the expectations are here for questions like these, whether acceptable for decimals or mixed numbers, or they want it as an improper fraction. I don't know, so I'm just covering most of my bases here. 19 over 4, like for me, if you were in like my class, Goldfish, I'd be fine with 19 over 4. But some teachers want the mixed number version, so that would be an equivalent answer in that regard. Or 4.75 would be the decimal answer to this, you know. So yeah, I'm just covering the tracks here. So 19 over 4 would probably be your answer there if they said, you know, you can keep it as an improper fraction. So 19 over 4 would be your answer for this problem if it was a fraction. Are you good with addition and subtraction of fractions? If you're good with addition and subtraction of fractions, then so Math Swatch is probably like the same thing as like my math lab. So it just depends on how they want the answer to be entered. So I don't know how they want the answer to be entered since you have it in front of you. But yeah, one of these three is what they want. So okay, that's good. If you have trouble with adding and subtracting, just let me know with fractions. That's fine. All right, and that's the end of that problem there. All right, so there you go. Nice. No, ask as many questions as you want, Goldfish. Go ahead, man. All right, I'm going to take the next question here, though, from Heide with 9.3 question 2. Okay, let's do that. How'd you do on the test, Heide? I hope you did well. Did good? Excellent. That's really good to hear. Nice, nice. All right, let me answer this question here really quick. Blah 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 blah. I don't care. Blah blah blah. No. Blah, blah, blah. I'm gonna just start over with this problem. So that's why I'm getting this wrong on purpose. And fine. All right. All right. Okay. So let's start from the very beginning here. All right. All right, so a simple random sample of size n is drawn from a population that's known to be normally distributed. The sample variance s squared is determined to be 12.8. Okay, so we have to construct a confidence interval here for the population standard deviation squared if the sample size n is 20. Okay, so for this one in particular, Heide, this is one of those things that you kind of have to reference back to the notes about. I'm gonna take this out here, because this one had a specific formula go with it, so hence why I'm bringing this up now. Okay, and that had stuff to do with, in this case, this guy right here. If we're going to get a confidence interval, this is the formula that we have to use here. N minus 1 times s squared divided by the critical value. We have two critical values here that we can find. Critical value 1 and critical value 2. Now I'm going to go through the process here about how to find both of those here, but we're going to use this formula here. Now I know it's been a while since we used it here, but we'll need to use the e-text as well in order to find these two critical values as well. So we'll see how that works here in this instance. All right. All right. So let's put this here. Okay. So in this first case here, we have a sample size here, n is 20. Okay, and we're also given s squared here, by the way. S squared is 12.8. That's just a random number that they gave us, and, you know, that's fine. It is what it is. So, you know, that's not a problem. Okay. So I'm going to go ahead and put this down here. So our n here, let me go ahead and put it down. N is 20. S squared here is specifically 12.8 for reasons. Now all we need to do is find this critical value here. Now, or both of these critical values here. So let's put these critical values down. Now, how do we find these critical values here? Well, first, we have to take note of two things. Of course, first of all, we have to take note of the confidence level, which is, in this case, 90%. So 90% confidence level, all right? And then we also want to take into account the sample size here, which is 20. Remember, one of the things that we're going to do in section 9.3 is to actually go ahead and find the degrees of freedom. Okay, remember that degrees of freedom here is equal to n minus 1. So we're going to have here specifically 20 minus 1, which is 19. Now that's going to be very important for what we want to do here in these problems. So you'll see exactly how this works here for this problem. It's really not too hard. But again, we'll see how it works. All right, so what we want to do here is we're going to go to a specific page in the textbook. So we're going to bust out the e-text for this part here. All right, let's go to the e-text. And hopefully this loads the first time. Sometimes it doesn't, so. And well, I luck out. Okay, it does. Good. All right, so we want to go to A-5. Now, A-5 is a, oh, not A-5 for this book. Let's go. Oh, you're off? Okay. All right, Goldfish. If you have more questions, please feel free to drop by my stream and ask as many questions as you want. If you're confused about maths, Goldfish, please feel free. Okay. I'm always here to help you. All right. A15? Maybe it is A15. Oh, good catch. All right. Very good. Yeah, it looks like Heide, you know more than I do. All right. I'm always here to help you, Goldfish, anytime you need it, all right? That's what I'm here to do, all right? Hey, it's A5 and... Okay, the reason why I said it was A5 because it's A5 in one book for my 102 class, and it's A15 in this class, which is weird, but okay. Like, it's practically the same book, but it has different appendixes. Like, fine, you win. I don't know what to do anymore, so... All right. In any case, let's work with it. Okay. When I figure out how to do things with my monitor, I'll let you know. Yeah. All right. So what we have here is a 90% confidence level. Now, what's important is that we need to take a look at two sides of this 90% confidence. All right. You posted on Discord. I want to see your drawing, Gemma. I think that'd be cool. It's going to be 10 times better than what I have. So what we have here is we have 90% here in the middle. If you want to kind of draw out a little picture about what columns to look underneath for this table, Heide. So basically we have 10%. We have 5% over here, and we have 5% over here. Okay. So at the end of the day, we have 0.05 for 5%, and then this is 5 plus 90, so this is 95%. So we're going to look underneath these two columns here with 19 degrees of freedom. Okay, and we're going to find our two critical values. All right, that's how we're going to approach this problem. So here's 19 degrees of freedom. Let's look at 0.95. So 0.95 has a value of 10.117. So I'm going to put that down, 10.117 as our first crit value. So that's a critical value. And then 0.05 with 19 degrees of freedom is 30.144. So that's our other critical value, okay? So does that make sense about how I found those critical values there, Heide? I hope that made sense about where we got those values from now. Okay. Now, let's look back at our... Oh, actually, yeah, I wanted to keep it there. Let's look back at our problem here. So let's go back to our problem here. All right, now our problem here says we have to have a lower bound and an upper bound. Now going back to one more thing, we'll go back to our formula here. We have n minus 1 times s squared divided by our critical value. That's essentially what we're going to do 2 times with both of these critical values. All right. So let's turn this up by 1. All right. So we're going to have here 20 minus 1 times s squared. Now, s squared here is going to be 12.8, straight up 12.8. You don't need to square this, Heide, because it's already s squared. It already tells you what that is, so be careful about that. And you'll divide that by 30.144. And then you'll do the same thing again. And then you'll divide that by 10.117. We're just going to do this twice, and we're just going to see what we get for both cases. Let's do it. Alright. So let's bust out the calculator. Actually, I'll put it on this side. And we'll take out the calculator. We'll do this together. We'll do it together on the calculator. Alright, so let's do it. 20 minus 1. I know that's 19, but we do 12.8. Okay. And so here we get 8.0679. Alright, repeat said process again. Alright, so we get 10.117, 24.0387. Okay. Alrighty, we have that. Now, let's go ahead and enter in these answers here into our problemo. Alright. So, the lower bound here is going to be 8.067. Oh, actually, they just want 2 decimal places, so 8.07. Alright, fine. If that's what you want, that's what you get. Okay. And our upper bound here to 2 decimal places, 24.04. Alright, fine. You win. Alright, good stuff. Alright. Now it basically wants you to do the same thing again, but now that you found the critical values, it just asks you to change the sample size to 30 instead of 20. So you're just going to repeat this process again, just with 30 instead of n, so you just take out the 20 and put in 30. That's all you're doing for part B, so let's just do it again. So same numbers here. Okay. Give me just a second here while I finish up this problem, and then I'll check it right out. Oh, actually, that's true. It does, doesn't it? Oh, right, it does. Right. No, you're right about that. Critical values do change because it's 30, don't they? Ah, yeah, you're right. Let's find it again, then. Oh, thanks for reminding me. I almost fell in that trap myself. The degrees of freedom here would be 29. Still, though, the same columns are going to be applicable here, so let's go back to those columns. Let's go back here. So what we have here? A lot of moving around, I know. So we have 29 degrees of freedom. I can fit it all on one screen. It's so hard right now. What's our critical values with 29 degrees of freedom? All right, under 0.95, that will be 17.708. Okay. And 0.05 here will be 42.557. Okay. Alright, now we rinse and repeat this process here. So we're going to, yeah. And I was like, the trap has been set because the sample size has changed. Like, All right, so we do 30 minus 1 times 12.8, because that didn't change. So 42.557. Yes, ma'am. I will do. I will not show it on the stream, I promise. I will certainly... I can follow those orders. I have a feeling Gemma will kill me if I do. I have a feeling I will be dead before this stream is over. Actually, let me look at it right now real quick. Whoop. Oh wow, lots of people. Ooh. Well, I'll say this, Gemma. That looks 10 times... No, yes, I will! No, I didn't, I swear. Do you want me to show it on stream or not? I can if you want, because it looks like 10 times better than anything I'll ever do. Okay, I know you would have killed me. Which is why I'm not showing it, okay? I promise. I promise. Fair enough. I'm not doing it, I already clicked off of it. I swear. I did. Let's see, what do I get here? 8.72. And what do I get here for the other one? I'll just take a shortcut for that. 17.708. I get 20.96, alright. So let's answer that. Alright. 8.72. Okay. You're fine, Gemma. You're fine. Don't be so hard on yourself, though. You put effort into it. Okay, so let's take a look here. It says, how does increasing the sample size affect the width of the interval? Well, we just increased it by 10, and so the width actually decreases because of the increased sample size there, Haide. So in this case, once we found the second one here, you'll find out that the width will decrease as a result, and that is correct. And now they just want us to do this again with a 98% confidence. You did your best, Gemma, okay? If you're happy with it, look, you did your best with it, okay? Don't be so hard on yourself. You're fine, you're fine. You did it with love in mind, okay, Gemma? Don't worry yourself over quality if you think it's bad. That's all that matters, you know? If you're talking about, look, let me show you my drawing of ND, okay? Here's my drawing of ND, okay? This is as much as I can do, okay? This is what I can do, alright? Yeah. We'll put some sort of nose there. Put this, and we'll draw some blondish hair here. Maybe put a little brown. I always make the streams interesting. Maybe a little bit brown streaks in there, you know. Look at this. This is my drawing right here. Okay. There. That's Andy. That's Andy, Gemma. Okay. I did it. It was by far the best effort that I have. I don't know why his eyes are a little bit disjointed, but I have a. I guess we'll just kind of go with that. It's going. Oh, he doesn't have blonde hair anymore. Well, I just think it's brownish, blondish kind of hair, Gemma. Forgive me. Forgive me. Forgive me. Alright, Heide. All we have to do for this part here is basically repeat what we just did from before. We have n is equal to 20 with 98% confidence. So 98% is just going to involve us doing the middle 98%. So we're going to have 1% here and 1% here. We're going to have 0.01 and 0.99 to be our two columns with 19 degrees of freedom. All right, let's find those critical values. Gemma's like, I expect perfection. I'm like, that's as good as I can ever draw. That's my length. That's my extensiveness of my drawing, Gemma. I'm so sorry. So I have 7.633. Let's mark that on the thing. 7.633. And Gemma's not going to talk to me forever. You're like, how could you do that? I'm like, I don't know how to draw. I want to share it on Discord with a channel where he shows art that the community has done. And Gemma, how about I do this? I can show him this picture on I can give Andy this picture and have him show it on his stream. You know, and then he was gonna laugh at me really hard, but then I'm gonna laugh right back. The 19 here is at 0.01, so 36.191. Okay, I need to put that down. All right, there we go. Let's do this, Heide. Let's finish this problem off. We have our two critical values now. Now we're ready to go. We have 20 minus 1 times 12.8. Divide that by 7. It's divide that by 36.191 first. Okay. Alright, so now I'm going to do this twice on the calculator here. Let's do it. Okay. 6.72. Okay, 6.72 you get for that. I will, however, allow you to show your viewers, guys, be nice. Okay. Okay. Are you sure? I'm just gonna ask your permission again so you don't get mad at me. Are you sure? That's okay. I don't want you to rage a haul at me, okay? That would be bad. So I always ask twice just to be on the safe side. We're at 31.86. Okay. Let me put the sensors down here. And I will show this on stream here. So lower bound here will be 6.72, which is correct. And my upper bound here will be 31.86. Yeah. And there you go, Heide. And all we have to say is compare the results with part A, okay? Does increasing the level of confidence affect the confidence interval? Yes, this certainly does. If you compare 90% to 98%, it makes this confidence interval wider. So the width will increase as a result, okay? And there you go. 9.3, number 2, is done and dusted. All right, of course. I know that takes a while because we have to hand do everything, but once you understand how to get those critical values down, it's really not as bad. You're just repeating the process like 3 times. All right, let's put this up on stream here. Is question 3 similar? Good question. Check that real fast. Yeah, question 3 will be similar, only you actually need to use the calculator to find the standard deviation first. So, and the sample variance. So you'll find the standard deviation, the sample standard deviation, and then you'll actually have to square that value. So that's the difference. You need to enter this stuff into the calculator, use 1var stats for that, and then copy down the standard deviation, and then you'll have to square that value in the formula. So unlike the last problem where it just gives you the variance as squared, this is not giving you the variance, it's giving you a data set instead. So you have to make that adjustment. Otherwise, the rest of it is exactly the same. So make sure to do 1var stats first to get the sample standard deviation. Does that make sense, Heide? All right, let's see what I got here. All right. All right. All right, there we go. I've put it on stream here. Is that a is that one of those Teddy Fresh parkas or hoodies? That looks like a Teddy Fresh hoodie, right? Yeah, that hoodie looks very familiar. I know, much better than my drawings, let me tell you. Let's do a side-by-side comparison here of how Gemma's drawing and my drawing, okay? I want you to show the greatness here. Look at this is a lot better than this, okay? I'm just gonna point that out here, okay? Let's just put the reference out here. Yeah. You can tell. On the left side, you have quality, okay? On the right side, you have myself, which is nowhere close to being exactly what the heck that is. So... I like it. It looks good. I'm not gonna lie. Look, I like it. I think it looks good, okay? I mean, look, you compare the two, there's a huge gap. Okay, a huge gap. You're fine. You're fine, Gemma. Trust me. Your drawing skills are much better than what I could ever put out. Okay? Just gonna put it out there. Did a great job on it, okay? done well. You've done well, Gemma. Definitely done well. See, you should be proud, Gemma. Nothing wrong with that. You've done a lot better than I ever would, like I said. See? There you go. Everybody wins. Alright. Does anybody have any other questions they wish to ask me? Please ask away. Ask questions if you like. I'm here. I am not going anywhere. I'm doing things. Things. Yeah. Maybe. Things. Oof. Getting beaten up. You do? Go ahead, Heidi. Ask away. Probably just need a new thing. No questions yet? Oh, you have an exam tomorrow. Okay. Good luck on the exam, Gemma. Have yourself a wonderful night, okay? Where am I? Oh, there we go. Ask questions, ask away, please. Well, yeah, today, technically. Have a good night today. Yeah. That was as awkward as I made it sound. Yeah. You leave here and wait for Heide's next question. If they would like to ask, go ahead. Oh, yeah. The earlier sections, I ain't gonna lie, the earlier sections are like questions like, wow, it's been like 5,000 years since I last did this. I can understand that. Okay. Let's go over this here. So, this section here was talking about group data and kind of like how to find mean around this group data here. Now, the important part here in this instance is understanding first of all, the class midpoint, right? Because that's what they ask you here first. Yeah, it's just a good refresher. That's true. So what you need to do here specifically is you need to go ahead and to take the class midpoint here, you need to go ahead and take the lower class limit plus the lower class limit of the first class plus the upper class limit of the next class, and then divide by 2. So basically, for that first class there, that first category, it'd be 61 plus 65, and then whatever that is, divide that by 2. Okay, so Natty, the best way to study for the final is do a practice test? Yes. Yes. Highly recommend. So we're gonna get 63 here for this. If you try all the practice tests, then, you know, but that's why I gave you a lot of time, Natty. That's why I've given you until the 19th for the finish. You have 12 hours of which to finish, so you get 3 attempts, so it's not like if you do bad the first time, it's not going to be detrimental if you give yourself more time to finish it off. So I know there's 55 questions on this exam, so but like I said, I pulled all of the questions from all of the exams, okay? From all the practice exams, because they're exactly what you saw in the tests. And I basically had a pool of 90 questions. I took out 35 of them, and I left the 55, which I felt were more important core questions. And that's exactly how I came up with the test. Like I said, I try to be as transparent as possible about how my methodology behind it, so it gives you the best opportunity to know what to study and be successful. So, highly recommend that you go ahead and do that. Just to kind of get comfortable with the questions. Write down the stuff for each question, whatever. Then try the test out. It will take you time, okay? It will take you time. It may take you maybe a day or two to finish because you can do a save this for later option, just like the previous tests. But again, just take your time. You have lots of time. You have 12 hours to finish. So, wanted to take away the anxiety here and give you plenty of time of which to kind of process it, do it, and then not have to feel too nervous or scared that you're kind of under the gun to finish, okay? Just 9 days, but, not the worst thing in the world. Actually, I gotta check something here about this. This is kind of a weird question because the classes are all unequal. Yeah, I know that. Yeah. Okay. Okay, good. Alright. Good. Yep, absolutely, Nettie. As simple as that. Same questions that you saw in the previous exams, the same type of questions, same exact questions you're going to see on the final exam. That's what I said before, and I kept my promise true to the end. So, like I said, complete transparency. So if it's not on the previous 3 tests, it's not going to be on the final. That's pretty much how it works. Simple as that. I promise you that, Natty. I never wanted to be like, hey, you have to, you. No, I don't do that. You know me. Try to keep it as easy as possible. I promise you that. I understand it's a tad bit anxious. Everybody has that right to be anxious and stuff because it's still a final. But hopefully it mitigated that anxiousness and that you can focus on doing the best that you can, okay? Alright, what's the next one here? Next midpoint here will be 65 plus 68. Hey, Natty, I just want you to do your best, Don't worry about getting an A or whatnot. You're going to do the best that you feel that you can do. And I'll be very happy with you putting forth your best effort, okay? That's all I want. I don't demand perfection, okay? I just demand for you to put forth your best effort and doing your best to make sure that you put yourself in a position to succeed in this course and that you can move forward. That's what I want. Thanks, Natty. Appreciate that. 65 plus 68 divided by 2. What is that? That's, what is that off the top of my head? I'm kind of forgetting off the top of my head. No, that's, okay, 66 and a half. Why did I blank out there? Then we do 68 plus 70 divided by 2, that'll be 69. 70 plus 71 divided by 2, that'll be 70 and a half. 71 plus 73 divided by 2, that'll be 72. 73 plus 77 divided by 2 is 75. And 77, I want to say, what would be the next one here? Okay, now I have to view an example for that last one. I really don't like that one. I think it'll be like this first one here. Okay. We'll go with 79 for that one. Alright. That should be... yeah, that's probably right. Alright. We'll check, and that'll be correct. Alright, so that'll be the first part there, Heide, for 3-3 question 2, is getting these midpoints. Again, taking the lower class limit adding it to the next lower class limit, and dividing it by 2. For this last one, I assumed that the next value would be 81, so I did 77 plus 81, and then divided it by 2 to get the 79. So I just had to make an assumption there in that case for that last class. Even though it's not represented, it's still assumed to be there. Okay? Let me know if you're with me here so far, Heidi. How would you know for the test if this question appeared on the test? If this question appears on the test, right? Basically, the one thing I would do is, again, just go with the formula here. If you want to find the midpoint, okay, this is a midpoint formula here, okay? Lower class limit of group 1 plus lower class limit of group 2 divided by 2. Yeah, for the last value, you have to make an assumption. Like, what would be the next value after 80, for example? Right? The next value after 80 would be 81, because you're just counting up by ones here, right? So that's how I know that the next lower class limit would be 81 in that case, right? Even if that category doesn't exist, 181 would be the next value. That's fine, that's fine. Don't worry about it. Cool. I think we have, yeah, all right. So the next thing that we're going to do here, Heide, is we're going to plug this into the calculator because we need these values, okay? So what I'm going to do here specifically is I'm going to use these frequency values, and I'm going to use these midpoints that I found here already in part A, or in this first part here. So I'm going to set up my list, go to my lists, I'm going to clear that. So for my first list, I put in the midpoints that I have from my problem. And then list number 2, we'll go ahead and put in the frequencies according to what is in the table. Okay, so I put in the midpoints and then the frequencies here appropriately depending on whatever numbers that you got. We'll then quit out of here. And then after that, we're going to hit the stat key. I'm going to go to calc. I'm going to go to 1var stats. And now we do want something here in the frequency list. We do want L2. So we have the list here will be L1, which is all our midpoints, and then L2, which is indeed the frequency list since we actually are given frequencies here in this instance. All right, and we'll go to calculate. So it'll be, again, if you have the old school calculator, again, it'll be 1var stats L1 comma L2, okay? It'll look like that. But if you have the new school calculator like I do, then you'll just set it up appropriately like you saw on the screen. Your frequency may be blank, so make sure, let me go back here for just a second before I do anything else. So make sure you have L2 put in here because you might be blank here. So it's 2nd and 2 to get L2 to show up on your screen, okay, Heide? On your 1var stats page. All right, so 2nd and 2 for L2 to show up there. And as you can see there, we have the sample mean. Sample mean right there is going to be 70.8. 1 decimal place, I guess, is what they want. So 70.8 is what we got. That's our sample mean right there. Yeah, you need the frequencies as well from the list. So whatever this list has your frequencies, you need L2 as well, right? So your sample mean would be off as a result, first and foremost. And they ask you for the sample standard deviation, and that's this SX here, which is 1 decimal place, so 3.5 is our sample standard deviation. For my values anyway, we'll check those answers, and I got it. And there we go. I got all 3 parts of this problem here correct. Bada bing, bada boom. Winner, winner, chicken dinner. Any questions about that, Heide? Hope that made it easier. Cool. All right, good, good. If you have any more questions, please feel free to ask. That one's one way back. Like the beginning of the semester, it's like, holy cow, that was so long ago. Oh my goodness. The remaining 3 questions? What remaining 3? Oh, you talking about that here? Oh. So U is the mean here, right? So that's what you mean here, right? So you need to do the same thing we did in the last problem here, right? So questions 3 from 5 here talks about the sample mean, right? So it's the same thing as this X bar here. You need to find the midpoints and you need to use the frequencies here. And then that's all you got to do pretty much. So that's what that U represents, is the same thing as this X bar that you have here. So you're just finding the same thing. U is just stands for population mean, but really this is the entire population you're testing over. You just, again, need the midpoints, and then you have the frequencies, and then that's it. So like this one here would be pretty simple, because then I just have the 55, 65, 75, 85, 95, and 105. I can delete this out. And then I just have the guys here, 3, 320, 1421, 1479, 277, and 10. Was there another one? No? No, okay. Alright. And then I just do the same thing again. Quit out of here, go to stat, go to 1-bar stats, rinse and repeat. So what do I get? 79.94, so 79.9. Alright. Standard deviation, that's what this symbol represents. Now, I want to see which one they want us to take into account, so I'll put in 7 point... Well, I guess it doesn't matter, they're both 7.8, aren't they? We'll just do 7.8. Alright, good stuff. Let's see here. Use the frequency histogram in the data to verify the distribution is bell-shaped. Yeah, it's actually pretty bell-shaped, I will say. Looks like a normal distribution. According to the empirical rule, 95% of the days in the month will be between what 2 temperatures? Okay, so this is the 2 standard deviations away, so it would be, what would that be? We take our mean of 79.9 and we subtract it by 2 standard deviations. So it takes 79.9, subtract it by 2 times 7.8, since we're using the 68, 95, 99.7 rule. So our first answer here will be 64.3. And then we just repeat this process here. Only this time we add by 2 standard deviations. Get 95.5 here. And I got it. Nice. All right. That'll answer question number 3. Good stuff. Easy peasy lemon squeezy. Not too shabby. Rabby. All right. Hopefully that'll make it a bit easier to do. Any questions for that? Got it. Nice. 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 All right. Any other questions? Any other questions for now? Hopefully that wasn't too bad. At least I hope not. Okay, that's fair, Natty. That's fair. I know there'll be a lot of no question. Yes, I understand the word yet. There are 3 more classes before, that's fine. You come back on Wednesday. Definitely I'm going to be here to answer those questions for the word yet. I have no problem with that whatsoever. I know there'll be some of them be like, I don't remember this, but guess I'll have to shake out the cobwebs again. It's like, that was 3 months ago. Holy moly. Yeah, no, it'll make you feel a little slow at first, but it's just again, it's just kind of going over those things just to kind of refresh yourself. It's like Heide said, it's just a refresh sort of thing. So the refreshing thing, that's the nice refreshing thing there. So there you go. Nothing wrong with reminding yourself of things that you've done before. So Ember just gives you a little bit of a leg up. Yep. Hmm. I'm guessing no more questions if I don't hear any. I'm just going to ask anyway. Okay then. Well, that's fine. That is not a problem. I think we answered a lot of questions today. No, I'm really happy. Look, I'm happy you guys even asked me questions. So sometimes I come out here, I'm like, oh, I'm so scared that nobody's going to ask me questions. I'm like, oh, but then everybody does. I'm like, yes! Look, I got things to review, so it's always important that I can get out the cobwebs for you. Put you in a position of better success. That's the most important part there. So, yes. All right. Ladies and gentlemen, I want to thank you all for coming out here to the stream today. I want to thank everybody, Gemma. I want to thank Natty. I want to thank Heidi. I want to thank Susan, who I know is in here. I want to thank all the guys from James's chat, Katie and everybody. I love everybody who came here to the stream. Thank you so very much here. You guys make this stream wonderful and exciting and fun. You guys are what makes this worth it every single day that I do this. I want to thank you all. I love you all. As always, everybody, as I like to sign off here, remember, stay safe, stay healthy, and most importantly, stay sane. All right? Have yourself a wonderful night, everyone. We will see you all on Wednesday at this same time, same place. All right? Take care of yourselves, and again, bring those questions back in a couple days. I'm sure we're gonna do more. I guarantee you, Heidi, we're gonna do some more questions. So bring the questions, and I'm gonna be here to answer them. All right? Have a great night, everyone, and we'll see you then. All right? Take care, everybody. Bye.